Hi guys, very good morning to everyone. Myself Satish Kumar, handling technical support engineer, representing AGS. This day, in the next 15 minutes, we are going to see what are all the various SolidWorks solutions that is recommended for the molds, tools, and dies design. What is the agenda today is what are all the latest trends that is coming into the market in day-to-day life, and what is the common challenges that is facing by these vertical mold tools and dies industries, and what is the traditional process they are following, and what is the recommended SolidWorks solutions to improve their day-to-day productivity and their design life cycles, and what are all the various SolidWorks functionalities that will make your productivity more, and that will reduce your time to market from your design stage to the end of the manufacturing stage, and what is the summary we are going to get from these presentations. So the industry trend is going on today is the global competition. So you all know there are a lot of competitive industries is developing day to day. So you need to be unique in the market to be first in the global competition, and you just want to reduce the labor cost, and you just want to shorten the delivery time while if you are making your design. So if you are spending your lot of time for to make a single design, that is not a more productive, and obviously you need to reduce the maintenance cost and also the injection time to improve your number of products you are done in your everyday. You can able to improve your accuracy also, so then only you can be unique in the market and be given in the quality products to the customers, right? So and also at the end, obviously you need to concentrate on the CAM to produce the NC programs for your VMC or CNC machines to do the machining operations. So these are all the industry trends that is available in our day-to-day improvements. And the common challenges facing by these kind of industries is they are getting a lot of files from their customers, right? So the data translation creates a barrier during the initial stage. So if your customer is giving some other CAD file format, means without any translation you can able to open inside SolidWorks, and also the CAD CAM integrations. Once if you done the design from the customer or you are doing your own, then if you integrate with the CAM, there is a possibility to data loss, and how it can be reduced. That makes a huge problem while we are machining, right? So and also the NC program for the machine operation is a tedious job to create those kind of inputs traditional method by manual. So here you can able to do automatically. So once if the design changes occurs, means you need to again create all those kind of things from the scrap. So how to reduce that? It all comes into a solution of time consuming process of your entire design cycle to the manufacturing, right? So this is also expensive to maintain and train all those kind of things during your process. So how these all things can be able to improve by using the SolidWorks, that is what we are going to see in our presentation. So the general non-integrated mold design process in a company is as like this graph. So first you are designing the part, and after that you are checking with is there any problem or repair with this design, and after that once if you done all this predefined analysis, you are discovering some draft is it is able to remove the core cavity properly, or is there any issues in the draft, and after that you just fix up all those kind of things. Then you are making a mold base or drawings for that, and once if you done all these kind of things, you are sending it to the manufacturing or integrate with the CAM to generate NC program. So once the design change will come, means what you are going to do is again you need to start up from the initial process to follow all these kind of things. So it is actually a time consuming process to do a single design in n number of days, right? So what is the SolidWorks integration mold design will gives you the productivity is, once if you make the design, and after that if you once find out the draft issues, and if you fix the draft issues, and once if you create the drawings, if any design changes comes, means you can able to switch over into any steps concurrently. So you don't want to again start it from your new design. You can able to directly modify the model that will automatically updated into the predefined analysis what you are already done, right? So this is actually a short process to do your mold designs, tool designs, and also the die design. So these are all the various functionality provided by the SolidWorks. We can access able to multiple CAD files from the customers without any data loss, without any translations. And during your design stage, you can able to find out the predefined analysis like draft analysis, undercut analysis, parting line analysis, everything. So you can able to do the top-down approach for the complex parts. You are not able to do the general mold tools. So in that, you can able to do the top-down approach to make complex parts mold designs easily. And at the end, you can able to create the error-free manufacturing drawing without any data losses, and also it is clear to communicate with your shop floor pupils. Once if you've done all those kind of things, you can have the CAM platform inside the SolidWorks, so you can directly integrate your model with the CAM to generate the NC program for your machines. So if any design changes comes in your model, means you don't want to again do all those kind of things from the initial stage. The software will automatically update the predefined analysis what you have done already once if you make the design changes. Yes. So we are starting with access multiple CAD files without any data losses. So as a mold tools designers or die designers, you are accessing a lot of different CAD files from your customer side, right? Maybe they are the user of Creo, Inventor, or Solid Edge, or NX, or CATIA, or something else. So if they are giving any files, you can able to access 30 different file formats inside SolidWorks without any translations. And also once if you import those files, you can also able to get the future history of the files by using the export tool inside the SolidWorks. So you don't want to spend your time to create all those kind of things to make any modification in the customer part. So in the display, you can able to see here around more than 30 different file formats you can able to access inside the SolidWorks without any translations. So let me quickly get into the software to tell how it works. So in the display, you can able to see here I'm having one of my customer file in the XT format. So I can able to directly access these files inside the SolidWorks without any translations. So once if I import, my software will give you the entire data regarding to that file, okay, without any data losses. So after importing this file, if you want to make any modification in that part, means you can also able to recognize the features using the export tools inside the SolidWorks. So you just want to tell the software I need this much of future for to make the modifications. The software will recognize each feature and give you the future history to make any modification in the customer part itself. So you don't want to create all those kind of things from the scrap again and again. You can recognize the future and make the modification, appropriate modifications, whatever you want, and save it as a new part. So once if you've done all the modifications, if you are making already the drawing for this part, that also will get automatically updated because there is a associativity in between the part, drawing, and assembly. Once if you make any modification in the part level or assembly level or drawing level, that will be automatically updated in the other two. Okay. So the software will create this part from the scrap. How if we manually create this part from the scrap, the software will automatically do the same thing for us. So if we are creating a new part and new mold designs, mean that are also we can able to create in an easiest way. because the tools that is available inside the SolidWorks is not much complex. It's like any other 3D CAD, so it is very user friendliness for the designer to learn this entire thing in a very shortest time, and they can also able to do any modifications in their design at any time. So they doesn't want any expert to work inside the software. Everybody can able to use it, and everybody can able to learn the software in a very shortest time. So in the display you can able to see here left side, you can able to get all the future history that is done by using the other CAD. And also if you want to make any modification in the part, you can able to instantly make the modification as like your own native CAD, and you can make all these changes appropriately and save the document as your modified document. So with this you can able to get all your customer files without any data loss, so you can able to ensure whether I am working on the right data. So the next thing is, before we are getting into the mold or tools or die design, we just want to check the manufacturing feasibility, whether this component is able to do the casting or not. Is it properly designed for the for displaying the more core cavity part in a proper way or not? You just want to find out that, right? So here we are having the predefined analysis like draft analysis, undercut analysis, partly line analysis, and also if you want to make your component scale to provide the shrinkage allowance and other allowance, you can also able to provide that. So these can be able to help you while doing the predefined analysis for your mold component to improve your day-to-day productivity. So let me take you into the software. So in the display you can able to see one of the camera plastic body. So this can be created by using SolidWorks. So once if you create this, I'll tell you how to create the core cavity for this camera part. So before getting into the mold tools, you just want to find out the terminologies that is available here, so you can able to do all the predefined analysis. And also once if you done this, how we are generally making the mold design, the steps is also as like the same as like what we are traditionally doing. So obviously we are checking the parting line, and after that if there are any holes means we just close that holes by using shutoffs, and after that we are just creating a parting surface for to split the core cavity, and at the end we are making the tooling toolbox as like our specification, right? So is there any core we need to insert means that also we can able to done by using here. So before getting into that, I just initially make my model scaling according to the centroid, or according to the origin, or according to the coordinate system I can manually create. So this can be provided as per your industry standard, how you are providing the shrinkage allowance, warpage allowance and everything. So once I scale the model, I can able to get the modified scaling model. So once if we're done this, I just want to check the predefined analysis. Is there any proper draft available in my model to split the core cavity in a proper way? So I can able to find all those kind of things. The software will highlight me in a color coding. The green color shows me there is a proper draft to remove the core in the top area, and in the bottom it will show me red. In the bottom, if it is a negative draft, that is not an issue, right? So once if you done this, and the next thing, is there any undercut analysis or parting line analysis you want to do, means that also you can able to done here, right? So after that I'll getting into the mode. I just want to create the parting line for this component. The software will automatically create the parting line for your component if it is simple. So if it is more complex means we can also able to manually create those parting lines as like what we want. So once if you done these parting lines, is there any holes means we need to close the holes to remove the core cavity in a proper way, right? So the shut off surface will give you the option to automatically fill the open surface. It will recognize and it will close it into the closed loop. It will close that holes and open space by using the surface, right? So after my holes is filling, I just want to create a parting surface to split up my mold into a proper core and cavity, right? So this normally traditionally you are making a powder coat in the mold box to split up the core and cavity. So as like that, here we are creating the parting surface. So once if you've done all these kind of things, at the end you need to create a toolbox. So these toolbox can be created as like your existing standard toolbox dimension, how you're having. So for example here I'm creating this toolbox for 4.5 mm in the length and 2.7 mm in the width. So this is what the standard toolbox I'm already having. So once if you've done this, you can able to create a proper toolbox for your mold design. So you can also able to adjust this toolbox as your part height, and once if you done this, you can able to split up the core cavity part in your handy, right? So once if you done this, you can also able to split the cavity part and also as well as the core part. So you can able to instantly make any modification in your part. Once if you've done this, is there any changes in your design, that also will get automatically updated. So once if you've done this, you can also able to give this part directly for your manufacturing. So for the manufacturing we need the NC program, right? So once if we done this, we can also able to directly integrate this 3D model with any CAD or CAM software. So in 2018 actually we are launching a SOLIDWORKS CAM for to generate the NC program for machining in 2.5 axis and 3 axis. So SOLIDWORKS CAM is capable for to make milling turning operations program, NC program for 2.5 axis and 3 axis. So with this you can able to do all those kind of predefined analysis, and after that you can able to make your die design with the ease of use tool. So in the display you can able to see here the software will automatically create the parting line for your component, and is there any holes, that also gets automatically recognized by the software and it will close. And once if you've done all those kind of things, you can able to provide the core cavity parts with all the runouts and everything. So the next thing we are getting into is press tools design. So the press tools design is such a tedious job to make properly define the stage wise dies. Preparing the dies is a tedious job. So how can we able to overcome those challenges using SolidWorks is you can able to create a configurations, and once if you've done the different configurations, you just make the step number of steps you want, and you just change the next stage configurations in your each step. So if any design changes comes means you can able to make all those design changes instantly, and in the design stage itself you can ensure whether your entire operation is going on sequentially or not. Is there any problems occurs while if it is making into the action, you can able to find out those kind of things during your design stage. So in the display you can able to see here one of the progressive die design that is already done. So I'll let me explain you how it is done easily. Okay, so for this strip design, actually what I want to do initially is I need to create my component first initially. So in this component, while if I am creating this component, I can also able to find out what is the exact blank required for to make this component, right? So once if I done this, I can able to create a different configurations that contains the different stage strips. Okay, so for example, in the initial configurations, what I'm having is, this is what the blank requirement for to do the output component. So in the next stage, what I want to do is, I need to make the two bends in the next stage, and in the third stage, what I want to do is, I need to make ensure these two bends. All right, so these kind of operations can be able to sequentially by using the different configurations here. So once if you've done these configurations, you can able to get all those different configurations into the action through assembly. Right, so in the assembly, you can able to see here the different steps is sequentially by using the assembly level configurations. So in each configurations, I'm actuating the different steps that is already created during the part level. So you just want to assign that and create as much as steps you want to make. So once if you done this progressive layout, in the top-down approach method, you can also able to create the toolbox, the die design for these press tools. Okay, so in the display, you can able to see here there are a lot of different die scope pins, and the bottom part and the top part is available here. So these dies can be able to done by using the top-down approach. So once if you done this strip layout, you can able to create these bottom dies and the top dies automatically through the top-down approach. Yes, in the display, you can able to see here these dies are created by using the top-down approach from this strip layout. So once if you done this strip layout, this is the easiest job to create the appropriate dies for these cavity portions. Right, so once if you're done these, you can also able to directly give these all those informations to your manufacturing through cam, because this is capable for integrate with any cam like master cam or edge cam or bob cam. So, and also if you're interested to working with the inside add-in SolidWorks cam, means well and good, you can able to do it for 2.5 axis, 3 axis milling and turning operations. So once if you create these instantly, if you are making any changes in your design, that also will get automatically updated. You are concentrate on your design, not on these tools. Right, so the next thing is, after we are making the component, obviously we are integrating with CAM to generate the NC program for the machine operations. Right, so in 2018, SolidWorks is launching the product called SolidWorks CAM, that is powered by CAMWorks. So it is capable for doing part and assembly machining. It is capable for doing 2.5 axis milling and also the 3+2 machining operation and the 2 axis turning. So in during your design stage, once if you done the model, you can put it into the CAM, and you can able to generate the NC program and also as well as the tool path simulations. So it is already having a lot of post processes as like your machine tool grips and also what are all the machines available in your standard, and what is the capability of those machines. You can able to provide all those information once, that will be saved, and you can reuse all those kind of things whenever you are making NC program. So this is what the SolidWorks CAM user interface. Once if you done the model, you can extract all the machining features. Here you are having one more advantage called automatic feature recognition, that will recognize all your features without any data loss. Right, so once if you done all these kind of things, at the end you can able to generate the post processes, the operation plan for your entire machining operations, and also that will give you the G code, M code for your machining operations. So if you want to make any changes in those codes, well, you can also able to do those kind of things. Here the two kind of options is available. One is knowledge based machining and another one is tolerance based machining. So that knowledge based machining is once if you set up some predefined setups for your CAM machine setup and also the tool grip setup, means that will capture all those kind of informations. And again, if you are making the same operation for some other component, means that knowledge based machining will give you the all informations you are previously used. So again, you don't want to spend all this kind of set of informations every time. So, and if you are providing the product manufacturing informations like tolerance, what is the reference datums, and what is the hole sizes, everything in your 3D annotations, that also having the capability to capture all those kind of informations inside the CAM. So let me quickly get into the software. Yes, so in the display you can able to see here one of the machining component that is available. So what I want to do is I just want to create the NC program for to do the machining operation for this specific part. Alright, so once if I done the model, the one unique advantage in SolidWorks CAM is the automatic feature recognitions. So once if you done the model, you can also able to recognize the machinable features by automatically through SolidWorks CAM without doing it manually, right? So this is what the operation tree you can able to see it in your left side, right? So once if you done the model, you can able to specify your machine here. So if you are having a lot of machines, 2.5 axis, 3 axis, 4 axis, 5 axis machines, means you can able to select the appropriate machine with all the appropriate characters, what is the maximum feed rate, what is the maximum spindle speed. Once if you done provide all these informations, every time you just want to select the machine, that will automatically capture all those informations. So, and also it is having a lot of different post processes and tool grips that is predefined. So once if you select tool, you can able to preview the tool, what is the size of the drill bit, and what is the diameter of the drill bit, and what is the length of my tool, and how it is going to be work. If you want to make any modifications, or if you want to make any changes in your tool grip, well, you can able to do all those kind of things. So the processor is also already available in your handy, so you can able to directly choose your machine that will export that all informations into your appropriate machines, right? So this stock manager is very easy to give the stock for your component. So once if you done the model, you can able to provide stock for these specific component in a different methods. So you can able to directly create the stock part, or you can able to import the STL cloud files, or if you want to make any customized stock for your material, means that also you can able to provide. So how much allowance you want to able to provide, that also you can able to give here. So once if you've done all this kind of informations, that will create a stock for your part. So once if you've done all these kind of informations, you can also able to create different coordinate systems, that is axis, where you want to start your operation to do all this kind of informations, right? So if you done all these kind of things, the software will automatically recognize the future what are all we need to make machining. So that will recognize the future and give you the future history, operation tree, to generate the operation plan and everything. So this will obviously reduce my time while I am generating NC program for my machining operations. So this is actually easiest job to create all those kind of NC programs through here. So here you can able to see here there are a lot of different operations that is already defined, that is already captured, and if you want to make any modifications in these specific operations, for example you just want to make changes in your tool grip or anything else, you can also able to do all those kind of things in your handy. If you want to make any operation changes, everything you can able to be done by using the easiest tools. So once if you've done this, you can also able to find out how much amount of time it is going to be taken. All right, so once if you done all these things, you can generate a tool path. Visually you can able to see how my cam is going to be work in here. So you can able to instantly see in your display how my manufacturing operations is going to be done. So in here you can also able to reduce your control speeds and everything to visual your stock and everything in your handy, right? So in the display you can also able to see how my manufacturing operations, my CNC will getting into work. You can able to simulate the toolpath to ensure all the operations what I am provided and what is the tool I am choosing is exactly right or not. I can able to find out all those kind of informations during here. So once if you've done this, you can also able to find out whether all my machining features is done or not. So after you've done all these kind of things, obviously what you need is the NC program, the G code, M code for to give the machine, right? So you can also able to generate all those kind of NC programs in your handy. So you can able to choose the post processes for your machine according to the different types. So once if you choose this, the software will automatically create the NC programs for your component to do the machining for your CNC using CNC or VMC, right? So once if you've done this, you can able to open this NC program in the editor, NC editor that is already available, comes along with the SOLIDWORKS CAM. So these can be capable to do the modifications in your NC program. So if you want to make any modification in your programs after if you export means, you can also able to do those changes in here. So and also once if you've done this, you can directly send this file into your machine without any translation. So if you're making any copy of this document, there is a possibility to make the design errors, or there is a possibility to delete or make modification in this NC program, right? So for that, to eliminate that, you can able to directly integrate these with your machine to all those kind of informations directly to the machines. So you just choose your machine and send this program to your machine. So with this you can eliminate your entire programming time from hours to minutes for even the complex programming parts. So through these, actually what is the summary we are going to get is, we can able to reduce around 50% of our mold design cycles through the easiest using tools, and also you can able to incorporate your customer design changes whenever the design changes came means, without affecting the delivery you can make the modifications instantly, and also you can able to improve your other CAD file format importing inside your native CAD, and also you can work as like your native CAD file without any translations. So this is actually a concurrent tool for design changes, and also for to make the entire mold design and to the manufacturing with ease of tools. So from these you can able to save your money for without spending your lot of time and money for the unnecessary work and also for the rework. Here you can able to save the time cost, and also you can able to improve your quality for the process. So if you have any doubts, you can feel free to contact us. In the display you can able to see the mail ID and what is our website. So you can able to see lot of different informative blogs that is available in our website. So if you are having any free time, you can feel free to see those kind of blogs to make your day-to-day productivity improvement. So we are at the end of webinar. So if you have any doubts, you can contact me through the number which is displayed in the screen. So these are all some of our customers, AGS customers, we are already having. So thank you everyone for watching this. Have a good day.